Chen, did you draw the negative 150? Where did it end up being? What quadrant? Thumbs up, thumbs down? Quadrant 3 is correct. 0, negative 90, negative 150. So there's my angle. So this represents negative 150 degrees. Damien, read the directions for us. Damien, question. What do you think a positive coterminal angle would mean? Okay, so do you think that would be adding or subtracting if I need a positive angle as my answer? Yeah. If I need a positive, he recognizes that full rotation should be a positive. So our given angle was negative 150. Damien, negative 150 plus 360? 210 degrees. Raise your hand if you got 210. Now, that is not the only positive angle. You could have added another 360 and get 570. Let's get a negative angle. Ricardo, how do I get a negative angle? Another negative angle. Should I add or subtract 360? Yeah, if I subtract 360, what do you get? Yep. Right, because if you're going in one direction, class, if I start here, how do I get, what does adding 360 mean? Which direction? We're adding 360. Which direction, class? Clockwise. Now, if you forget like me, you could just look at the clock. And which way do I go? Up or down? Remember, for positive, did you guys watch the animation? Remember we did it? Yes? So we are going which direction? Against the clock, right? So that would be a plus 360. And if you went the other direction, you would get a negative. So this is a positive. And if you subtract, you get negative. Tomorrow we're going to do the radians. Alright, so we're going to find a positive and a negative angle that are coterminal with a given angle. This one is in radians. I know it's in radians because there's no degree symbol and it has pi in there. We talked about yesterday writing your given angle here. The number of rotations, sometimes they use it as a variable n. Is this going to be a positive or negative rotations based on the positive or negative angle we need? And then the measure of the angle, which we had said was in radians, and then this is going to be my new angle, the coterminal angle. Now, because they gave me a fraction, you're going to work with fractions. So I have 2 pi over 3 is my given. And I just want one positive, so I can just do one full rotation. But this, for this example, our rotation is in radians. So one full rotation is, how many in radians? 2 pi. Okay, it's not 360 like yesterday's lesson. It's going to be 2 pi. So let's work this out. Now I have 2 pi over 3 plus 2 pi. There is some bad news. The bad news is these are not common denominators. Therefore, we cannot add the fractions together. But we can make them friends by having something in common. Class, how do you make this a fraction? Mathematically, how can I make this a denominator of 3? I'm going to multiply it by 3 over 3. I can multiply any number times 1, and this will give me a fraction I need. So 2 times 3, so 6 pi over 3 is equivalent to 2 pi, yes? Remember, treat pi like a variable x. And now I just add the numerators. 2 plus 6 is equal to what? 8 pi over 3 is my positive answer. Notice how they gave me a fraction, and I'm going to end my answer in a fraction. Now, let's try a problem where it is a negative coterminal angle. So, I'm going to start off with 2 pi over 3. And instead of doing positive 1, what do you think I'm going to do? Negative 1. Okay, negative 1 times 2 pi is minus 2 pi. And we already did the equivalent fraction above. That's going to be 6 pi over 3. Class 2 minus 6. Positive or negative? Negative 4 pi over 3. My two answers are going to be 8 pi over 3 and negative 4 pi over 3. Okay, let's do a little more fun. You might be asking, where is that? Let's now, instead of counting the quadrantals, they call these quadrantal angles because it separates the quadrants, 1, 2, 3, and 4. Let's now, instead of counting them by degrees, we're going to count them by radians. Okay? So I have 0 radians. It's kind of weird. I'm going to put 0 pi. Because 0 times anything is? 0. Okay. If I do a full rotation, then it's going to be what? 2 pi. And they're not equal, but I'm trying to show that they're at the same location. Okay? Okay. What is half of 2 pi? 1 pi. So instead of 306 degrees or 2 pi for a full rotation, half is just 1 pi, or 180 degrees. Okay? Okay. Let's say you take half of this now. What do we get? If you took half of that, that would be 2 pi over 2 times 1/2. And if you multiply across, what do you get? 2 pi over 4, you cancel your 2's and you get pi over 2. So I have 0 and 2 pi. I have 1 pi over 2, so 0, 0 pi over 2, 1 pi over 2, 2 pi over 2. What do you think this one's going to be? 3 pi over 2. We're just counting, right? 0, 1, 2, 3, and this one is really 4 pi over 2. Okay? So what I just did there is I found the quadrantal angles in radians. Okay, to give ourselves an idea where 2 pi over 3 is, let's pick a color. Let's pick purple. These do not have denominators of 3. And we have to find a common denominator. My common denominator is 6. So, how do I get them to be 6? I'm going to have to multiply this one by 3 over 3. And if I multiply this by 3 over 3, I get 6 pi over 6. I'm going to put it in a circle. Over here, let's just do all the quadrantals. If I want a common denominator of 6, I'm going to have to multiply this number by 3 over 3. And I get what? 9 pi over 4. And if I come up here, and I want a common denominator of 6, what do I do?
Not 9 pi over 6?
It is a 6. You're right. And how about this one over here? 3 over 3 gives us what? 3 pi over 6. And really this one is 0 pi over 6. Lots of fractions, I know. So let's count. 0 pi over 6, 3 pi over 6, 6 pi over 6, 9 pi over 6. And if we're counting by 3s, what do you think that one's going to be? 12 pi over 6. This one I have to multiply by 3 over 3 as well. Okay, why did we do that? What's the equivalent fraction of 2 pi over 6? Yeah, if I multiply by 2 over 2, I get 4 pi over 6. And put your finger where you think 4 pi over 6 is. I have 0, I have 3, I have 6. So 0, 3, 4 is over here somewhere. And it's closer to 3 than it is to 6, so somewhere up here. And what I'm trying to show you is that, remember that is our initial, there's your terminal side. This is where 2 pi over 3 or 4 pi over 6 is, and then basically all we're doing there is just full rotations, right? For a positive angle, I just add 6 pi over 3 and I got 8 pi over 3. You end up in the same location. Or if you do it the other direction, you go negative, then this would also be negative 4 pi over 3. So the pink, the green, and the purple there end up in the same location. They just have different angle measures. What's hard about fractions is radians have to be worked in fractions. Now, I do want to highlight this calculator. If you don't know it, you can learn it. Watch. And I couldn't figure it out this morning, but I can do it on this calculator. 2 pi over 3. 2 pi is at the bottom there, divided by 3. And what you can do is you convert it there and you press enter. You can get this number. I'm not going to press anything. I'm just going to add 2 and then pi, because that's what we did over here. And this calculator can actually add fractions and with radians. 8 pi over 3. The best thing I can do with a graphing calculator everyone say alpha y equals. It turns a menu here and it has n to d, and that tells you a fraction. So instead of, I can't put pi in here, but I can put 2/3. And if you add it to 2, it will give you 8/3. And you just put your pi in there. Does that make sense? So that's the best I can do.